Good afternoon, everyone. Today's lesson, we're going to tackle about heuristic problem solving.
What is heuristic? The term heuristic from the Greek means serving to find or discover. In the context of problem solving, heuristic are experientially derived cognitive rules of thumb that serve as guides in problem solving processes.
Heuristic guide problem solvers by helping them simplify choices regarding the numerous, immensely complex, and imperfectly understood the factors that act simultaneously to shape the problems. If you need to make a quick decision, there's a good chance that you will rely on a heuristic to come up with speedy solution. Heuristics are mental shortcuts that allow people to solve problems and make judgment quickly and efficiently. Common types of heuristic rely on availability, representativeness, familiarity, anchoring effect, mood, scarcity, or trial and error.
What is rule of thumb mean? Think of this as mental rule of thumb strategies that shorten decision-making time. Such shortcuts allows us to function without constantly stopping to think about our next course of action.
However, heuristics have both benefits and drawbacks. The strategies can be handy in many situations but also can lead to cognitive biases. Becoming aware of this might help you to make better and more accurate decisions.
History of the research on heuristic. Nobel Prize-winning economist and cognitive psychologist Herbert Simon originally introduced the concept of heuristic in psychology in the 1950s.
He suggested that while people strive to make rational choices, human judgment is subject to cognitive limitation. Purely rational decision would involve every alternative potential cost and possible benefits. However, people are limited by the amount of time they have to make a choice and the amount of information they have at their disposal. Other factors such as overall intelligence and accuracy of perceptions also influence the making decision or decision-making process.
Limitation of heuristic in problem solving. Heuristic do not guarantee correct solution to problems. Being based on generalized rules of thumb, heuristic may yield only approximate solutions.
Effectively selecting and applying heuristic seems to require some conceptual and informational expertise. One type of misapplication commonly occurs when problem solvers use heuristic in a situation where logic and probability theory would have been more effective.
How heuristic are used? Heuristic play important roles in both problem solving and decision making, as we often turn to these mental shortcuts when we need a quick solution.
Here are a few different theories from psychologists about why we rely on heuristic. First, attribute substitution. People substitute simpler but related questions in a place of more complex and difficult questions. Second, effort reduction. People use heuristic as a type of cognitive laziness to reduce mental effort required to make choices and decisions. Fast and frugal. People use heuristic because they can be fast and correct in certain contexts. Some theories argue that heuristics are actually accurate than they are biased. In order to cope with the tremendous amount of information we encounter and to speed up the decision-making process, our brains realize on these mental strategies to simplify things so we don't have to spend endless amounts of time analyzing every detail.
You probably make hundreds or even thousands of decisions every day. What should you have for breakfast? What should you wear today? Should you drive or take the bus? Fortunately, heuristic allow you to make such decision with relative ease and without a great deal of agonizing. There are many heuristic examples in everyday life when trying to decide if you should drive or ride the bus to work. For instance, you might remember that there is road construction along the bus route. You realize that this might slow the bus and cause you to be late for work, so you leave earlier and drive to work on an alternate route. Heuristic allow you to think through the possible outcomes quickly and arrive at a solution. While they can help us figure out a solution to a problem faster, they can also lead to inaccurate judgments about others or situation.
Heuristic aren't inherently good or bad, but they are pros and cons to using them to make decisions. Understanding these pros and cons may help you better use heuristic to make better decisions.
How can heuristic can lead to bias? They can also introduce errors, bias, and irrational decision making.
Heuristic can certainly help us solve problems and speed up our decision-making process, but that doesn't mean they are always a good thing. Heuristic can lead to inaccurate judgment about how commonly things occur and how representativeness certain things may be. Just because something has worked in the past does not mean that it will work again. And relying on a heuristic can make it difficult to see alternative solutions or come up with new ideas.
Heuristic can also contribute to stereotypes and prejudice.
Because people use mental shortcuts to classify and categorize people, they often overlook more relevant information and create stereotype categorization that are not in tune with reality.
Benefits of heuristic in problem solving. As guidelines for problem solving, heuristic prove surprisingly across a wide area of problem types and problem contexts, proving remarkably accurate in both laboratories and real-life contexts. Successful problem solving is a function of how efficiently, rather than how strenuously, a problem solver works, and heuristic enhance efficiency regardless of whether the problem is well structured or ill structured. Some studies suggest that heuristic reasoning processes appear most useful in concrete situations. In fact, heuristic can help produce results that are comparable to problem-solving strategies that take into account all available information and employ complex computational processes.
Good day everyone, my name is John Michael Cortez and I will be your presenter for patterns and formulation of conjectures. Mathematical investigations involve a search for pattern and structure. The Latin word conjecture translates into throw together. Now, once someone proves a conjecture, it is called a theorem. Basically, a conjecture is an unapproved theorem or theory. An example of this is that students may find it challenging to generate a diagram that matches the following conditions or to determine whether their examples are even distinct from each other. The conditions are: draw a map showing towns and roads such that each pair of roads has exactly one town in common. Each pair of towns has exactly one road in common. Every town is on exactly 3 roads and every road contains exactly 3 towns. Now this diagram would show something like this one. As we can see, every town is connected to 3 roads and every road is connected to 2 towns, at least 2 towns, which satisfies the conditions said on the previous slide. Now we need to be systematic. We may find many solutions to a problem but still miss interesting ones if we are not systematic in our search. We have to create a path that will take us through all the possibilities that might arise. A complete search for even this small case of four rectangles requires careful reasoning. I'll show you in a bit what those rectangles is. There are two ways to put a rectangle in this corner. Now, symmetry comes to our aid. We have to define what we mean by a distinct answer, and that the subdivisions has an infinite number of solutions. Now, why do we say the subdivisions has an infinite number of solutions? We'll see why. Now, in this first figure here on the left side, we'll see that the topmost part of the rectangle is shaded, and what is stated there is that the whole rectangle should be subdivided into four rectangles, meaning the first subdivision, this shaded part is included in the four subdivisions. So we need to divide this unshaded part into three rectangles. Same goes for the for here in the right right rectangle. So for the first figure, these are just some of the solutions where we can subdivide this rectangle into four different rectangles. Here, as we can see, we divided it into four. This second rectangle also is divided into four. This one, also this one, also this one, and this one. Now for the second rectangle, we also subdivided it into four. These are just some of the solutions where we can subdivide the rectangle into four rectangles, smaller rectangles. This is the shaded part, and here are the rectangles. 1, 2, 3. The second one is also a rectangle. Now for figure 4, three rectangular subdivisions are turned into four. Now from this part here, from this rectangle, we only have three subdivisions. Now how do we make it four? There are obviously an infinite solution on making it a subdivision of four, but these are just some of the solutions where we can subdivide it into four. The first one is we divide the middle rectangle into two smaller rectangles, making it a four subdivision. The second one, we divided also the yellow part here, where we made a four subdivisions also on the rectangle. And the third one, we divided the bottom rectangle into two smaller rectangles, making it also four subdivisions. Organizing data. We need to try to organize the data in a way that will highlight relationships among our problem's variables. Numerical data can be organized in tables. Note, it can be organized by tables that facilitate our search for familiar patterns. In a problem with two variables, one dependent on the other, the information should be listed according to constantly increasing values of the dependent variable. So if the values are increasing, we need to list it accordingly for the dependent variable. For example, a student wondered about the number of regions formed by the diagonals of a regular N polygon. She systematically listed the numbers of sides of the polygons and the number of regions created. Now, in this figure, a table of the number of regions made by the diagonal of a regular n-gon. This will go so on and so forth. Here is another example. In 1899, George Pick published a formula that gave the area for a polygon whose vertices lie on the points of a square lattice. This is, if someone will be questioning what is a square lattice, this is a square lattice, a square with points, distinct points. Discovered that the area could be determined based solely on the number of lattice points within the interior and the boundary, which is the B of the polygon. This formula was A equals 1 divided by 2B plus 1 minus 1. Figure 7 shows a polygon with 2 interior and 10 boundary points, which has an area of 2 plus 1 over 2 multiplied by 10 minus 6, which in turn is equal to 6 based on George's formula. Now, if we try to look for patterns, we need to organize the observations that we make in order to develop conjectures about the behaviors of the mathematical objects that we are studying. Because if we're not gonna organize the observations, we will not have the capability to prove that our conjecture is true or correct, meaning it will not, in turn, it will not become a theorem because we don't have enough evidence to prove that our conjecture is true. For conclusion, heuristics are essential mental shortcuts that allow individuals to make quick, efficient decisions in complex situations. They can lead to cognitive biases and irrational decisions, especially when applied in situations where logic and careful consideration will be more appropriate. In essence, heuristics are a valuable part of human problem solving, but their power comes with the responsibility of knowing when and when not to rely on them. So not all conjectures are reliable unless they are proven to become a theorem. That would be all. Thank you.